Hello and welcome. In this lecture, we're going to be bringing in a GameDev utils namespace package that I have produced with a library class called lazyValue. We're going to see how to use this lazyValue and how it can save us lots of code and lots of heartache when dealing with things that need to be initialized a little bit later than awake and need to talk to other classes. Let's dive in and see how it's used. So in this video, we're mostly going to be making use of an asset that I've produced called the lazyValue. Now, this is in an asset pack for you. It is a script, but we're just going to be using it like any library as we would using a Unity class or using a C# class. So don't worry about the implementation details unless you really want to. I'm just going to go ahead and import the asset pack. You should have it to download and import against your lecture. And the idea of the lazyValue class is that it works as a container for those values that we don't want to initialize in awake, but we want to be safe to access. Basically, they'll be initialized when we first use them. So let me show you an example of how the lazyValue script gets used. So we'll go into our health component, and we want to protect, say, our health points. We want to say, okay, so this is being initialized in start, and it might be possible that it gets queried outside. What if we ask for get health points in start, for example, in the display script? Who knows? Maybe we want to choose to do that in the future. And we should basically, based on our guidelines, make sure that everything is available in start. All our state should be fully initialized, or at least safe to use. So the lazyValue script allows us to do this by wrapping the type. So that instead of using a float here, we're going to use a lazyValue, and here we need to include, so if I just put in a space so it's using the right thing, for whatever reason, it wasn't giving me the option to complete that until I put these two chevrons around the float, which is how we're going to need to use it. So it's going to be lazyValue, chevron, float, chevron, and we need to include the namespace gamedevtv.utils. So this now is a lazyValue wrapper or container, if you like. If you hover over the class, you can see some documentation about it, that it's a container class that wraps a value and ensures initialization is called just before first use. What do we mean by initialization? Well, we mean this bit here to the right of health points where we get its initial health. Okay, so that makes sense. We are going to be using it like that. That means that now our default initialization here isn't going to work because it's a wrapper class. If we actually want to get to the value of this wrapper class, we have to do healthpoints.value. And as you can see from the documentation of that, it will get or set the contents of the container. So we can use this to get the value out, or we can use it to set the value. But that's not how we're going to use it, at least not initially. So we're not going to do our initialization here in start because that would be a bad idea, right? If we had to wait until start till it's initialized, it's not safe. So what we're going to do is we're going to initialize our lazyValue in awake, like so. And you're saying, hang on, Sam, but we don't have the ability to call to base stats in awake. And you would be right. So what we do is we use the very cool feature of the lazyValue class where we can say, hang on, lazyValue, we're going to create a new lazyValue. So new lazyValue of type float like this. And then in the constructor for the lazyValue, we need to pass it an initializer delegate. And we've used delegates before, and the context in which we've used them is events, but you don't have to use them as events. You can just pass them, use them as a way of passing function pointers around as arguments. So that's what we're going to do. We're going to create a private function that returns float, and it's going to be called getInitialHealth, like so. And it's going to take no arguments, and that is the signature of this delegate. It needs to take no arguments, and it needs to return float because this is a lazyValue of float type. If it was of int type, it would have to return int. So then all we need to do is take this initial value for our health and basically do a return of this. If I had typed my return correctly, that would work better. Now, and get my spaces. Okay, so I need a semicolon on the end of that line in awake. And what I can now do is pass this delegate in. Now note, I'm not using parentheses on the end of it because we're not calling the function yet. And that is a crucial thing. because in awake, we are initializing the lazy value, so the health points is set to something and is safe to use because of the lazy value will initialize it before it first gets used. But we are not calling get initial health. We are just passing it to the lazy value, which will use it when we need to initialize, when we need to use it, basically. So now we can go throughout our class in the places that we're using health points and just replace health points with health points.value. So we just add a .value on the end here, and that goes in and reaches in and gets the value out. And what that's doing is it's basically saying that when we want to get this value, we need to make sure that it is fully initialized, and it will call the initializer if necessary right at this point so that it has its default value. So now we could call take damage in start, and even if start hadn't been called in health yet, it would make sure that we had got the correct default value for health points and everything would work as we expected. Same thing down in get health points. We're going to add a .value on the end, and that's going to make sure that if we get health points, it will have been initialized. And the same thing in percentage, and the same thing in regenerate health. And let's see, any other places? The capture state, we need to make sure it is returning the value rather than the lazy object. And the same thing in restore state. Let's just check that all the locations of using health points is now using the value instead. Yep, looks like it is. Okay, so that's great. So if something calls to health points and tries to query health points in start, it will get initialized. But there is an opposite case, which is the possibility that nothing calls to the health points before start or during start, and it's not until some update way down the line that we actually use health, and so it gets initialized to its initial value. And that might be okay in the case of health, but I just want to show you that one of the features of the lazy value is that you can do health points.force init. So in start, we can do health points.force init, and this will mean basically if at this point we haven't already accessed health and caused it to initialize, we will do it now. We'll do it now in start and make sure we take a snapshot of the health points right now at this point. Now, this isn't so important for health, but for some of the other classes that you're going to use it in, it might well be very important. So let's just have a look at other things that are still using start and might still be initializing some state in start. So we've got our fighter class. Yes, that's initializing a weapon that could be dangerous. So we're going to leave that tab open for something that we want to work on. The projectile, I'm not worried about setting the transform. The AI controller, yep, the guard position, that could be potentially a problem again. The mover has nothing in start, so I'm going to actually remove its start altogether. We have got health, which we have already updated, and base stats, which has got current level, which is currently guarded against, but couldn't we do that neater if we were using the new lazy value? So these are the scripts that I want you to update. We've done health, but I want you to update the current level in base stats, the fighter's current weapon, the AI controller's guard position, and the mover we said we don't care about. So these three classes is your challenge to go ahead and implement a lazy value for the state that they are initializing in start. Pause the video and have a go. Okay, welcome back. So let's just rinse and repeat the process from before. Current level is an int, so we're going to be doing a lazy value of the int type this time. And we're going to have to include the right game dev utils. And then what we're going to do is in awake, we're going to be setting up our current level equal to the lazy value, so new lazy value, and then we need to go ahead and put in a delegate in here. Now, actually, you can just put in the calculate level because calculate level already is something that returns int and takes no values. So it basically calculates the level exactly as we'd want it to do, but now we're just going to do it the first time it's called. And then in start, we want to make sure that that level has been calculated, so we're going to do a force init. And everywhere else where we've got the current level, we can do just a .value on the end. like so. In here, in update level, we'll do a dot value, current level dot value. Oops, not too many dots. There we go. And then where else have we got current level? Got it down here in get level. Now notice we can simplify this away because we no longer need to check whether current level is set up. We can just go ahead and access the value. We can do current level dot value, and we know that that will initialize it if it wasn't already initialized. So that simplified our code. Lovely. I love it when we get to simplify code. And that's it, I think. We have basically got everything else. The current level is not used. So we've updated everything to the value. And the only thing is we don't set an initial value for the current level because it doesn't have one. It just gets that lazy initialization. Now I'm going to go ahead and quickly repeat the process for both fighter and AI controller. Now, you notice what I'm going to be doing here is just stripping out the bit that sets the current weapon and making that a separate method. So this is going to be the one that I'm going to call attach weapon, like so. And so then attach weapon I'm going to call up in the set default weapon. And the weapon I'm going to attach is the default weapon, and I'm just going to return that default weapon. So now it's vitally important that I call the current weapon dot force init, because otherwise we're not going to have a weapon in our hand. So this is the case that I was talking about. Very important that we do a force init in start, because otherwise we won't have a weapon visible when we start the game. Let's go ahead and look for all the values. So that's the fighter converted over. Let's now have a look at the AI controller and do the same thing for the guard position. And there we go. Everything has been updated to the lazy value, and we can be safe in the knowledge that nothing is being done in our start methods, so that everything basically is ready to go after we have had our awake. Once we get to start, everything is ready to be called. All our methods are now safe. Hooray!